Okay, so let's start. Now, first of all, uh, these are the project files for your assignment. Now, first of all, this is the server VI, right, and this is the client VI. Now, from the client VI, we will be controlling the server VI to process different share images, right? And what it does, it will compare the template image. So the template image is this. So it will compare the template image with the incoming image or the current image, and it will detect whether the image contains a pi or not, and if it does contain a pi, whether it is the same as the template or not in terms of shape and color as well, right? So without wasting time, let me run this. When I click this, the first image gets loaded. So it says number of processed images 1, and image 1 did not contain a pi, which was not the correct color. So this is not neither a pi nor its color is correct, right? So let me click it again. So when I click it again, it says number of processed images are 2, and number of matches are still 0 because we haven't found the correct template image. So it says image 2 did contain a pi because this is the image 2, the red one, did contain a pi which was not the correct color. This is a pi, but the color is not correct. Let me move forward, and then there is a white one. It says the number of processed images are 3. Still the number of matches are 0 because we haven't found any object with the same color and style. So it says image 3 did not contain a pi which was not the correct color. Next, then yes, so it detects image. You can see also the red rectangle, the square, and it says number of processed images are 4 and number of matches are 1. So we have found one object. If you click it again, so there is a next again yellow one. So it says the number of matches are 2 and the number of processed images are 5. Since we have processed the 5 images, so if you click it again, it will roll back to the image 1, but this number of processing will keep increasing until you stop it. So let me click it again. So this is our first image, but it says number of processed images are 6 because we are counting again. So this way this is working. So when your images are 10, it will have a number of matches 4 because we have 5 images, and we know that there are 2 images that are the same as our template image. So this is how this project is working. So this is for the demonstration purpose. In the next video, I will add the complete explanation of this project. So this is the code of our server. Let me move downward because this is our main code. Now this code is based on the state machine pattern, right, as described in the description of this project. So starting from the very first case, let me show you the folder first. So this is the folder from which I am getting the images. You see, so the images that you have shared, so I have named as image A, B, C, D, and E, and these images I am so their names are here: image A, B, C, D, and E. So there are 5 images. So this is a 1D array, and I have stored their names here, right? Now, and this is our template image because we are detecting this yellow one because we have 2 yellow objects, so it's better to detect these yellows rather processing 5 images and counting for 1 only. You can also take the red one if you want. So from that folder, basically, we are extracting the image. Now, first of all, you need to know that what is the state machine. So in the state machine, basically, you have different states. Now, in the current scenario, we have 4 different states. Let me show you. So we have load main image, which is the image to be processed. We have load sample or template. The template image is the image that is we are going to compare with the main image, and then we have object and color match. So we need to detect the object and as well as its match its color pattern. And then we have result case. So in the result section, we are basically processing different information that we have extracted, whether the object is detected or not, or different counters that are running in order to process all this. So first of all, you can see this one. This is the outer or the main loop. It will kept on running, and after this, you can see there is a case structure. So this is case structure. This case structure will execute when you press the button from the client VI. Now this is the boolean. Basically, this is the local variable of the boolean. So when it gets true, the true case will execute, and when it gets false means you have not pressed the button. So this false case has nothing in it inside. There is nothing. It's empty. Only the wires are going. And in the true case, it contains all our main code, right? So when you click the button, this true case executes, and when you enter into the true case, we can see there are different wires such as number of image processed. So these are different wires which carries the information, and in the start they carry 0. So these are the shift registers. So we need shift registers in order to hold our information so that we can add the counters and increment them whenever the certain condition is met. Okay. So first of all, when you enter into this true case, you can see there is a for loop which has number of iterations as 4. So since our main the states are 4, load main image, load sample, object and color match, and then results. So we are running it 4 times, right? So during starting, we have a load main image. So this will come here, and inside the for loop, we have another case structure which contains 4 different states. So in the main, so the state machine starts from the load main image. So this case will execute, and what it does is it basically loads our main image, the image which is going to be processed, which is going to be compared with the template. So what it does, this is the array, and this is the index. So in the very start, you can see there the index is 0. So this 0 will come here, and we will be processing the image A, and the image A is basically this one. So after the image A is processed, we can see that so here we are generating the address that is based on the name of the image, the format at which the image is saved, and this one is the application directory, the directory where our images are saved. So this one is basically this. So we are extracting the image directory and their names, and we are giving to this. This is build path. So it is creating a path of that image, and it is giving to this IMAC read file. And here, what is happening? This is IMAC create. So it is used to create a memory location for the image. This is our source image. you can call it the image for which we are going to compare. So it will create a memory location for the our main image. Then this will create this will read the our image which is placed at this particular address. After we get the image, so we are basically clearing the different overlays. Here we are clearing the different overlays which might be present in the previous iterations. So after this, the states moves on to the load sample. Now we have loaded the main image. Now we will move towards the load sample. So the next state is our load sample. Now in the load sample, you can see we are loading the image, namely as template yellow. So this yellow template is already placed in the folder template yellow. The similar pattern is followed. The name of the image is template. So we are again creating the memory. We are loading that image. Now here basically the magic is happening. So we are extracting the features of this template. First of all, this is what we can press Ctrl S from the keyboard. It tells us that this is the IMAX setup learn color pattern. So the image that is going to be loaded, we are extracting its different information like color and shape and shift information. So these are the information that we are going to extract from this template image, and then we have a IMAX learn color pattern. So these so the image is written into it, and then we are learning different features of it, like its shape, its color, and different features. So, and we are giving it to this indicator. This is the template indicator. If you double click on it, we will redirect it to here. So this is our template image. Now after this, the state machine goes to the object and color match. So in this state, basically we are getting both the images. This one is the local variable of the template, and this one here we get the image, the main image that we have extracted in the first iteration, because we haven't wired anything in the load sample. You can see that this is directly going through it, so it holds the previous information. Okay. After that, we are basically comparing, or we are finding that if whether this contains that object or not. So I'm a match color pattern. We are basically matching. This is our source image, and this is our template image. So we are comparing it, and then if we found any object, so this number of matches will contain a number, and it will tell us that these are the number of objects with a certain color that are present in the image. And here we are overlaying the pattern matching. Means if we have a number of groups of objects, so they will be overlaid and they will be present. So this is basically a sub VI, and this is placed inside this overlay pattern matching results. Now while opening this into your system, if this file is missing, you can just replace it. You can right click it, and you can simply replace with sub VI content, and you will come here and you will replace it with this. This is the same. There might be some error in the address, so that is possible in your system. So after this is our main image, so it will be shown this one, right? And after this, you can see that the information, the number of matches is basically moved toward this shift register, which holds our information, right? So all other wires are simply passing through it. Only this writes the information. The below one is for the index. Since our images, names of the images are placed inside an array, so each time this case executes, we need to increment it by 1, and we need to write that. Okay. Now in the result section, we are processing different things. First of all, you can see that number of image processed. So each time this true case executes, it will add an increment, add 1 to it, and this is basically a number of process element, and it will be loop back to this shift register, right? After this, you can see no image number. Sorry, this is no, but not. This is the number of image found. So in the start it is 0, and then basically we are adding the object found with it. So this wire is basically added with this indicator, and then it comes here, and it indicates that these are the number of matches. Right? You can see different information here. So this all is basically to generate an output based on whether we get an image or not, or whether the pi is detected or not, or whether the index is greater than 4 or not. If the index is greater than 4, since our so I'm talking about this particularly that how we are repeating the the image information. Like after image E, how we are coming back towards again image A. So this magic is happening here. Since our array contains the 5 images, so starting from the 0, 1, 2, 3, 4. So maximum we need 4 index. If the index is incremented up to the 4, greater than 4, then we have to roll it over. We have to make it force it to go to 0. So here we are checking whether the index is greater than 0, greater than 4. If it is yes, then we need to send the 0. Otherwise, we need to keep sending that the same index. Here we are checking if the object found is 1. We need to send did, otherwise didn't. If it is greater than 0, we need to find was found or was not found. Right. So this is how the things are working here. This is basically based on the state machine pattern. And after this, we have just wired that okay. Since there are only 4 iterations, so this will not execute after this, but we have just deliberately wired it as load, go to the main image, but it will not execute since the number of iterations in the loop are 4. So this does make sense. Okay, so this is our main loop. Now beside this we have two other different loops. This one is the server TCP connection, and this is used for the UDP connection. For the TCP connection, we have an open TCP connection. This is the function from the taken from the TCP palette. And then we are basically reading the TCP, right? Since the client will send the information to the server, so we have to read it. Now, if it contains information, it will run this default case. Otherwise, it will run an empty case, saying that no information is received from the client. So, if the client press button, so this new image will get a true value, and it will come here, and it will be written to this new image, right? So I have hide this indicator since we don't need to show it on the server. You can show it by clicking this show indicator. I have it in it. So this is the TCP read. We are reading it and we are defining that our data type is boolean. So I provide it as false. This is our new image, and then at the last we are closing the connection with the TCP. Similarly, this one is the UDP. So from here from the main loop, you can see that after loading our main image, this is our main image. We are basically using the local variable. We are writing this main image to this loop, which is basically a UDP connection. So we are transferring our main image to the UDP via this. So this is the UDP open. We are opening a UDP connection, and then we are writing UDP write. So what we are writing an image. That is our main image, and we are transferring it via UDP to the client. And this is our UDP close. So this is the whole server VI. So this is our server VI, right? Let me explain the client VI. Client VI is very simple. So the client VI, let me resize this. So in the client we have again two different loops. The one is basically let me make it right a little faster. So this one is basically the TCP listen. Now we are going to send the data from here to the server. So this is TCP listen, then we have TCP write. So we are writing this Boolean data, writing its length and the data to this using the TCP write. Then we have a TCP read. We are reading whether the time out or not. Then we have different error handling techniques. If there is any error, this will run. Otherwise, this will be skipped. Right, and then we have the stop mechanism with the TCP close connection. If there is any error, this will execute. Otherwise, this will not execute. And the UDP side, we have a UDP open, then UDP read. So we are reading the image, and then UDP close. This is just a simple code. So open the UDP connection at port 601, then read the data available. So we are reading the image, and then close the connection. So it will continuously running and keep monitoring the server data from the server. So let me run it again to show that. Oh yeah, it's working. And it's counting the images, right, detecting the objects, and we can see different information here. Thank you. This is all about our project.